the Chatelier's principle. On the higher paper, you need to predict what happens to a reversible reaction at equilibrium when you change its conditions. The rule that lets you do this is called Le Chatelier's principle. It states that if you change the conditions of a system at equilibrium, the position of that equilibrium will shift to oppose or counteract the change you made. In other words, the system always tries to cancel out whatever you do to it. The three conditions you can change are concentration, temperature, and pressure. In the exam, the position of equilibrium tells you whether there's more product or more reactant in the mixture. Shifts to the right means more product forms. Shifts to the left means more reactant forms. Changing concentration. If you increase the concentration of a reactant, the equilibrium shifts to the right to use it up, so more product is made. If instead you remove or decrease the concentration of a product, the equilibrium also shifts to the right to replace it, again making more product. The system always moves in the direction that opposes your change, either using up what you added or making more of what you took away. In the exam, a common application, in industry, products are often removed as soon as they form. This keeps shifting the equilibrium to the right and increases the yield. Always state which side now has more substance and why. Change in temperature. Temperature changes depend on whether the forward reaction is exothermic, gives out heat, or endothermic, takes in heat. If you increase the temperature, the equilibrium shifts in the endothermic direction to absorb the extra heat. If you decrease the temperature, the equilibrium shifts to the exothermic direction to release more heat. So, for an exothermic forward reaction, raising the temperature actually shifts the equilibrium backwards and reduces the yield of product. In the exam, first identify which direction is exothermic and which is endothermic. The question will tell you. Then apply the rule. Heat up favours endothermic, cool down favours exothermic. Always link the shift back to the yield of product. Change in pressure. Pressure only affects reactions involving gases, and it depends on the number of gas molecules on each side of the equation. If you increase the pressure, the equilibrium shifts towards the side with the fewer molecules of gas. This is because that reduces the pressure again. If we decrease the pressure, the equilibrium shifts towards the side with the greater number of gas molecules. To answer these questions, you must count the number of gas moles on each side using the big numbers in the balanced equation. In the exam, always count the moles of gas on each side first. Increase pressure, then the equilibrium goes to the side with the fewer gas molecules. If both sides have the same number of gas molecules, changing the pressure has no effect on the position of equilibrium.